Now let's speak of the definition of the last two functions, which is the void callback as well as the handle update function. So void callback, it means that if there is any update in the topic, or if the topic that the if the subscribing topic, that is when you press the button on the Node-RED UI, if if it tallies with one of the topics as specified in the code, then this void callback is invoked. So here what we do is, first we say that callback was invoked. If callback was invoked, then we start comparing, like if the topic that the cloud is using to subscribe tallies with the response topic, then you return that. You just print the response. If it's tallying with the reboot topic, that means that it is telling the NodeMCU that you need to reboot. Then you'll restart your ESP and you'll print rebooting on your serial monitor. If there is an update, then it will call the handle update function, that will be defined down. Nextly, the final thing, whenever the topic and the subscribe topic tally, then handle update is again called. That is, once you, for instance, you press the light on button, then the command light on will come from the Node-RED to the IBM Watson, and from the IBM Watson, as we have our device connected, it will come to the device and get executed. In what way does it get stored is all about written in handle update payload. So let's get on to the final function definition, which is the handle update. This is invoked whenever you are sending, whenever the node MCU is subscribing to the command sent from the Node-RED UI. So just like you have declared a static JSON buffer for publishing the data, in the same way you are declaring a static JSON buffer of size 300 for the commands that are being sent from the IBM cloud to the Node-RED, to the node MCU through Node-RED, IBM Watson IoT platform, then to the node MCU. If, as we know that root is a place where the final command gets stored, that is a command in the form of JSON is stored. If you don't receive any command in root, it means that handle update parses failed. If you receive, what you do is, under root, whenever you are sending any command, it will be stored under the string command. So for instance, you have the command light on, that is coming from the Node-RED to the IBM Watson IoT and to node MCU. Finally, it will get under the root, it will get stored in the command. So what you are doing is, you are storing that command in a string called value. So now we are at a phase where once we press the light on command from the Node-RED UI, the command gets stored in a string called value. We have finished till here. Now let's continue. So here what we do is, once we are varying the slider value from 0 to 100, there should be an analog write that should be written on these LEDs. Right, there should be an analog write that should be written on LEDs, which should vary from 1023 to 0, because this is an inverse LED. So for that, what we do is, we take an integer variable called v1, and when we vary the value from the slider, that gets stored under root, it gets stored into value 1. So we assign an integer called v1, and similarly we do the same thing for slider 2 and slider 3 and store it in the integers v2 and v3. After which, as I told you, that when we are doing analog write on an LED, it should be from 0 to 1023 conventionally. But as we are connecting and a basic shield, and the basic shield has inverse LEDs to it, so we map it from 1023 to 0, because it's an inverse LED. Nextly, let's come to the phases where the commands are being sent from the Node-RED UI. So as our functionality is, if we vary the slider to a specific, to control the illumination to a specific percentage, and then click on the light on button, then the LED should switch on with the respective illumination. So what we have done is, as we have mapped the value, that is from 0 to 100 that we vary in the slider, to 1023 to 0, so we directly analog write that value to the pin D1, so that by pressing the light one on button, we not only change the state of the LED from light off to light on, but also see that it is switched on only when the illumination is the illumination that we have adjusted in the slider. The same functionality we have we have written for the light 2 on, and as well as you can see it's for the light 3 on. And light off is generally, as we know, it's an inverse LED. So to once we make it 1023, it will become light off. So the same functionality has been applied for light on and light off. That is, we analog write it with 0 for light on. As it is an inverse LED, it will get switched on if we give 0, and for light off we give 1023. Finally, the update that was given from the by pressing the button from the Node-RED UI, it will be stored in a JSON object and it will be printed. That's what this is all about. And now the coding part, where we have coded our node MCU connected to the basic shield with pins D1, D2, D3 to LEDs L1, L2, L3 and A02 LDR programming it phase has finished. Thank you.